Howdy students, I am going to show you in this video how to install and use graphical analysis. It's a really powerful tool that's going to help us graph and analyze data. We want to find slopes. Slopes are really powerful in physics, and I want to show you how to use this nice tool. So the first thing you're going to have to do is get to Vernier graphical analysis. There are two ways you could do that. Either you could just Google Vernier graphical analysis in the App Store, or you can follow this link, bit.ly/install graphical analysis. Type it out just like that, and it should bring you right here. Once you are here, you should be able to add it to Chrome. And you're going to add the app. So after you have added the app and added it to Chrome, it should show up as one of the apps that show up right when you open your Chrome. And then you can click on it. So your graphical analysis should appear like this. We're not really going to be able to do sensors or data sharing. So what you're going to use it for is manual entry. So you click this right here. And now you can enter your data, and you should see as you enter it that it populates right here. So I'm going to pull up the data from our worksheet. So here's the data from our worksheet. I'm going to enter it in. So you can, in the X, that's going to be what's on your X-axis, which in this case is time in seconds. So you can just enter that in. And then the Y is going to be what's on your Y-axis, in this case height. If you hit enter, it'll move between the cells, and it might be a little faster to enter. 0.4, 0.75, 0.46, 1, 0.5, 1.25. So now I can make this big again, and if it didn't look like it in the past, it should appear now that this is not nice and linear. And if we want to check if it's nice and linear, what we can do is we can click on this guy down here, this little graphing tool, and that's going to open a lot of things up. We won't often use the rest of these, but we will use most often apply curve fit. And that's going to fit different types of things to it. Now, if you want to check what type of line it is, or curve it is, I should say, you can use these. I like to just look and see if it's linear. And you can see this does not look like a line. You know, that's an actual line where, you know, the slope is the same all the way across. It does not fit it very well. These dots are very far below it. These dots are very high above it. And you can also check the regression here. The closer it is to 1, the more close it fits that line. So this is not a good line. So you can also add another data set. So you click these 3 dots up here. You can add another data set. And this is where you can add the rest of your data. So again, because this was a quadratic line, again, we used our table to figure that out. You can also use apply curve fit to figure that out. But we're going to graph, instead of x versus y, we're going to graph x squared versus y. In this case, t squared versus y. So it's going to be 0, 0, 1024, 5, 0.6, 0.75. I'll move me 0.2116, 1, 0.25, oops, and 1.25. So now, if we maximize that and we come down here, and here you can change what is being shown. I'm going to show both data sets, data set 1 and data set 2, because the first one is just the first one we did, and the second one is the new data. So if we, where it's x squared, and if we do that, and we apply a curve fit to that, and yeah, we're going to use linear, you can see that the blue line here, you see the blue here, is much closer to a line. That line curve of best fit is much closer to a line because it's regression of 0.9985, which is very close to 1. You can also see that it fits much better. And then again, if we check this, R, that is going to be 0.9606. That is not close to a line. And you can see it's not as much closer. But also, the important things, remember, it shows you the equation for a line y equals mx plus b. Our m is this value right here, which is nice and important. We're going to get back to this value because it's actually going to remind you of another value that we're going to talk about quite a bit in the next unit. And then b as well, you can see it gives a b, but this number is really, really small. In fact, if the number is less than 5% of your slope, it's going to be, pretty much 0. So you can pretty much regard it as such. However, this one, it is, also quite small. It's a little below this that the y-intercept is. But again, it's pretty small, so it's pretty darn close to 0 as well. But again, this is not a great line to represent our equation because it's nonlinear. But this is why we linearize, so we can get a nice relationship here, and we get a nice slope here, which we can use in the future. So I hope that was helpful. You can play around with graphical analysis a little bit and get used to it because we're going to use it quite a bit. And I hope that helped.